Okay, another quick tutorial video on activity 15. This is the activity I like the most. It's the most involved, but we really start to get to play with the robots and what they can do, how they can measure inputs, and how we can make decision outputs to affect where that robot goes. So there's a couple files here. We're first going to look at the activity 15 PDF file. In this activity, we're going to talk about the IR sensors. These are the sensors that read the difference between white and black. We're going to talk about compass sensor, so we can get a compass heading, and then motor control, how we control the speed of the motors. So first, be careful whenever you turn on your robot and the board is on the robot, the board is going to remember the last program that was uploaded to it. So this means that the robot could just start driving off the table once you turn it on, so please be careful. So looking at problem number 2. Zumo sensor array calibration. This is the file where we're going to use to calibrate the IR sensors, the sensors that tell the difference between black and white, and then how we can read the values off of those sensors. There's two different ways to read the values. We're going to look at both of them, but we have to calibrate them first so we can get a better reading. So we're going to go and we're going to upload this. Pay attention that when you go to calibrate, you actually have to wait till the yellow LED on the robot is on and then push the push button. Okay? Then it will do a back and forth spin, and then you're ready to start reading. So let's turn over and we'll show what that reading will look like. So push the user push button, and then I start having my readings. I have minimum values, I have maximum values. Minimum values correspond to white, black values correspond to the high values. So minimum values correspond to white, maximum values correspond to black. And that is in the comments at the beginning of this code. Okay. So remember, read through those comments. It's also in further down here. Okay. And the way that this right now, this code that's running is working and functioning is it's reading an individual sensor value from each of the sensors. So there's 6 sensors. So sensors 0 through 5, left to right. Okay, now I can identify as I move the robot across the black line, the high values correspond to where that black line is relative to the robot, relative to which sensor. So it looks like I have a black line underneath my sensor 5. All of the other sensors are low, so they're probably seeing white. So this is a way I can tell what I'm looking at. This is the code that's run here. Okay, it pulls out every single individual sensor value and prints it using this for loop. Okay, num sensors is just a variable that I've set, and I've set it to be the number of sensors I have on my robot. The next part of this activity wants us to comment that part out and uncomment another part of the code. So we'll do that. So I want to comment this out and uncomment this. This is now my second way to read values, measuring where the line is. And this is a single, and I'll upload a new version here, a single value, the weighted measurement across all 6 sensors to tell us where that line is. So I have to do a calibration once again. And now, depending on, and this is really where the comments come in handy, but depending on what that value is, I can identify where the line is relative to my robot. If I'm directly over the line with my robot, basically the robot is straddling that black line, and I'm directly in between sensor 2 and sensor 3, my sensor value should be at 2500, right? So with that, if I want to say that's my target to stay at 2500, I could do an error equation using the measured value I'm measuring to calculate how far am I off from center of that line, in the positive direction or in the negative direction. That'll be a very helpful way to get your robots to follow that line keep straight on that line. Read through the comments, in the code, okay, work with these files, work with this code, play with it, okay.